Hi, everyone, and thank you for joining us. My name is Eyal. I'm a cloud security architect. I worked in financial services, healthcare, and high-tech organization. I've been working with cloud services since 2015, and recently I've published a book called Cloud Security Handbook. We have here with us Rich Lindberg, which is the CISO of GEMS, and we also have with us Dr. Shamim Naqvi. Shamim is the CEO and co-founder of SafeLiShare.
Yeah, my name is Rich Lindberg, as stated. I'm a 25-year industry veteran. Been working in this space for a long time in a lot of capacities, seen a lot of things. Like all of us, we are all responding to the increasing concern and enforcement through law and regulation, other regulations on data privacy. So this is top of mind for me, and I'm very pleased to be here.
Thank you so much, Eyal, for having me on here. And just a little bit of background. I worked for a number of years in Bell Labs, learned a lot of things from the Unix lab, research lab luminaries. In particular, had the great pleasure of working with Doug McElroy, who was a very famous security technologist researcher. I then went on to do a few startups in the Boston, Massachusetts area, and SafeLiShare is my fourth startup. So I'm looking forward to a conversation with you two gentlemen. Thank you for asking me.
Today, as part of our Privacy Day, we will talk about confidential computing and how it allows organizations to protect data in the cloud. Organizations have been sharing data in the cloud for over a decade now. And we know that as we share data in the cloud, threats are coming and we need to protect them. Rich, from your experience, what are the best practices for data privacy preservation in cloud and in SaaS services?
Well, that certainly adds a layer of complexity because you're talking about managing all of this outside of your own walls, which means that you're giving up some control in order to gain the functionality that's offered by the service, whether it's a SaaS, pure SaaS, or provided as an infrastructure kind of thing, as by like storage. So the complexity previously we relied on contractual transference of risk and believed that these services would simply protect us. What people have, or organizations have learned over time, is that they're at best a shared responsibility platform in most cases. And that means that the organization has to take a proactive approach to auditing and ensuring that third-party risk is managed or that the configuration is implemented. Depends on the service we're talking about, of course. But you can't just rely on that the third party doing what you would do. And this becomes a real critical point when it comes to your own third-party attestations to your business partners or to any kind of regulatory body, or including cybersecurity insurance when you make your declarations page. When one makes your declaration to the cybersecurity insurance, you're going to probably think about your own enterprise and respond that way. The problem then is if you're outsourcing some of your data warehousing to a third party, and they are doing something different than you are, then you may be in contrast to your declarations page or that third party attestation or to a regulatory body, because you've not considered it in this context. And that means that you may be denied coverage in a claim case, or you may have misrepresented essentially your risk to a business partner. And if something goes the wrong way, they may, claim damages because you did not disclose properly. And of course, at the end of the day, you're the custodian of that data. And if you outsource some of it to a third party, the government's not going to care. They're just going to say it was your job. So, what did you do? Why did you let them do that kind of problem? It's definitely complex. And you asked me about recommendations or best practices. And I think the first thing you have to do is really look at the practical problem of audit your third parties to make sure that you know what they're doing, so that when you draw attestations out or plan your cybersecurity strategy, you take that into account, knowing what you have in terms of data inventory and technical workflow. if you can't get that straight, you can't protect. So that's my starting advice.
So, Rich, you previously mentioned changes in privacy laws. Can you elaborate more about new laws regarding to privacy, data privacy?
Well, certainly. Privacy is changing. It's going to transform IT and cybersecurity. We have been seeing trends where, well, we've been seeing a trend where third-party accountability has become more of a thing. One notable example would be the New York Cybersecurity Regulation 500, where in the financial space, if you want to do business with New York, you need to provide them an attestation. If you're outside New York, you need to provide an attestation to them about what your security postures and controls are like. And if they are non-sufficient in type and robustness, then the entities within New York will be prohibited from doing business with you. So if you're a bank or, I don't know, in the stock market or anything to do with something that roots to New York, you need to have controls or you can no longer do that business with the financial center of the world. So that's a big deal. But that the trend is that not only is the source of authority like a government or a regulatory body, in this case, in that example is the state of New York, but there's examples with the federal government and different state governments around privacy laws that are saying not only do you need to keep data private, but you need to have that reasonable security control, which is a vague term, but it has to be debated by your general counsel as to what that means. And I have opinions about it, but you need to seek your own legal advice. But you need to have that enforced and in a robust way, and you're going to have to be able to evidence and defend that statement. So your approach to if you don't want to hold yourself to account on a robustness of privacy controls manifested as cybersecurity controls and workflows, then your third-party business partners will, or the state or federal government will, because of regulation. And even if none of that applied to you, if you want cybersecurity insurance, they're going to hold you to that because they do root cause analysis on why companies were breached and why they suffered a claim and a loss. And they're not going to insure you and let you transfer risk unless you have a certain minimum set of controls in place. And that idea of a minimum set has really gotten expansive in recent years. There are more companies that are being denied insurance altogether. And it's gone from a simple one-sheeter a few years ago to multiple pages, a few dozen controls that you need to put on your declarations page. And if you fail to meet enough of the controls, they're either going to charge you a really high premium or they're going to say, no, you're not insurable at all. And then if there is a claim and you can't defend or provide evidence that you did in fact have something in place that's relevant to the root cause of the breach you may be incurring, they may deny your claim even though you were covered because you did not properly represent it. And at that point, your kimono is open. There are forensics investigators involved. They will know what is and is not true. So privacy law is driving change. The other thing that's happening on an organizational level is that the board of directors are being transformed. The SEC made a move, the kind of likes of which they haven't done since 2002, when they made a requirement for publicly traded companies to have a financial competency in the board, which is where CFOs really rose to prominence and to direct conversations with boards. They're doing the same thing in this year where the board has to have a cyber competency. And so what we're going to see, I think we're going to see, is that the person in charge of security, usually referred to as a chief security officer or some flavor of that title, is going to be answering questions, tough questions by the board. And even though that we're talking about the publicly traded companies, board members sit on all kinds of companies, so public and private and whatnot. And these are the expectation is going to become normalized to every company because of this cross-pollination of board members, that security is not going away, and it's going to be specifically measured. So laws driving it, government partnerships driving it. If you want to do business with the government, you're going to have to adhere to these same kind of expectations of third-party risk, attestations to them, or you're going to be denied that revenue stream. And it's just going to be normalized throughout the entirety of our business world, nationally, internationally. So that's how privacy regulation is driving change, and why we need to have the conversations like we're having today about private computing and other ways to protect data.
Are there any measurements that we can take to ensure that information remains secure even when we share it across multiple platforms, like SaaS services and cloud services in general?
Well, absolutely. It's about data management, and privacy laws focus on data, the proper maintenance, storage, and use of data. So that means data at rest, and data in use, and data in transit. Those three categories. None of this is new. These are principles that go back decades at this point. It's just, people were sort of a little bit laissez-faire about how things happen. They say, well, we have access controls in our environment, so that must protect data at rest, but it really doesn't. We know this. Encryption, the standards are more specifically required in most cases. Data in transit, well, are we using a secure encrypted channel to do that? And are we providing the proper access, authentication, access control to those resources coming and going? It's not new, it's just more specifically stated on the level of robustness and the manner of the robustness that you need to achieve what privacy laws essentially are calling, quote unquote, reasonable security controls. And then some cyber insurance and statutes or regulatory compliance standards like NIST or whatever you want to cite are going to call out very specific things. And the reality is that because they are more discreetly called out, we can't rationalize with a general equivocation like a lot of organizations try to do in the past. You actually have to have something to meet a particular control, and they often specify the robustness of that control. And the more we go down this path as organizations, and we fail to step up to the need, the more regulation we're going to end up with, and the less choices we're going to have, and we're going to be forced into building more than we should maybe for our organization. Security doesn't have to be Fort Knox. It just has to be a reasonable balance to what you're protecting. So you don't want to overdo it, but you need to not underdo it either, or you're negligent to your business. Security should not be considered a cost center. It's protecting the business and allowing robust confidentiality, integrity, and availability controls to exist. If you value your business, you need to put some wrappers around it all. And that doesn't mean you need to go crazy with it, but you should have an appropriate measured response. And if you don't, because you have to do that, you can only do that if you measure process, data flow, all that. So I know I went down a rabbit hole, but at the end of the day, I'm really saying understand your situational awareness, understand what is valuable in your business with a business impact analysis that considers all the systems that support a business workflow and treat them all with the same level of care, and put an appropriate level of investment into protecting it. And one thing, let me just wrap with this. Investment shouldn't mean dollars, because there's many ways to achieve a particular outcome. Dollar investment is about, how well you shop, and how much effort you're going to put in versus how much you're going to buy with an easy button solution. And there's nothing wrong with either approach, because an organization's core competence should be about their business. But that said, we do have IT administrators and core routine people. A CFO maybe, has nothing to do with core business in most cases. It's about an internal focused role, but we consider it vital. Same thing with IT and cybersecurity. So you have to have a reasonable approach to solving those problems, and a defensible way to articulate it.
We talked about protection mechanism. Let's talk about the different angle. What are common security vulnerabilities of application runtime environment in the cloud, which eventually leads to data breaches?
Well, there's cloud storage, which is just a container, and that has to do with a good identity and access management program. So know who you are or who's accessing your stuff. Know what your data is, know the data sensitivity level. You need a data classification program and a data protection program in large. So measure the robustness to the sensitivity. The sensitivity often correlates to a business impact that you can measure in dollars if you put the effort in. That will help you gauge what's a reasonable percentage of dollars to invest. But again, it's not about how much you're investing, it's about how effective the coverage of the controls are. So identity access management, role-based access controls for one. Obviously, when you get to a more runtime environment that's not just a data storage container, you need to apply, you need to check the runtime, the living, breathing runtime environment itself, because if you don't appropriately harden or securely configure an environment, then the general purpose nature of any environment, whether it's the operating system or the application, such as a web service, database service, whatever it is, or even an API, may just it's built to freely exchange data and interconnectivity, because that's its purpose in life. But that openness and ease of use also leaves it open and ease of hack. So you want to configure responsibly how someone can access data, or any asset, whether that's a system or data, but any resource. And in the case of data, you want to make sure that it's going to who you intend it to go to. However that happens, whether it's data storage or API or any kind of presentation layer through an application, make sure you know who you're dealing with, and then make sure that it's wrapped with the appropriate level of encryption for that transmission, and you should be able to audit it all. So if you want to safely share information, you need to understand what your workflow should be, how the data moves, and are you meeting the standard against the classification? I mean, are you acting appropriately?
And since our main topic for the day is confidential computing, how would you define confidential computing, and how does it work?
So confidential computing, I come from a DoD background amongst other backgrounds. And so when we think about confidential computing, we think about who's the right audience? Are we wrapping appropriate controls around that data and that operational function? And so we might have different security levels in a network, for example, or the data itself. So every network really serves data, and data is used for operations. So it all comes back to data at the end of the day, and how you store and move it. So secure computing has to involve data protection, data-centric approach to security. If you can control identity and access, so you can control data classification, then you can bring the two together to apply the right controls. Doesn't matter what your environment is. It comes back to who it is, how robust the data protection is in terms of encryption and access control, and then I feel like I'm being a broken record because it's really as simple as that. I keep coming back to it because people get distracted by, 81 different layers. I kid you not, something like 81 different layers is best practice. If you look at the Northrop Grumman security fan, that's a tried and true. There's a lot we have to do. But if you were to distill things, when there's a breach, we often distill things down to a root cause analysis. Why did something happen? And if you were to look at the Center for Internet Security Critical Security Controls, which is a nonprofit approach to root cause analysis on breaches, it really comes down to know what you have, know who you're dealing with, and know where your data is. And the rest of it is just layers that sort of build on that. So I always try to never get away from focusing on a data-centric approach to security. Did I answer your question? I feel like I went down in the rabbit hole.
Yeah, a little bit. I would say someplace like resolving the problem of, we know how to resolve data encryption at transit and at rest, but someplace in between, we need the confidential computing because eventually data resides in use. So we need to protect it as well. What would you say the benefits of confidential computing in terms of privacy enforcement technology?
Well, there's a lot of different mechanisms out there, and I've seen them kind of come and go over time. I haven't really seen anything new. I've seen, fresh approaches on it all, but it still comes down to how are you going to keep your hands around access to data? The tricky part really is once it leaves your borders, how do you keep control? Is there a way that you can track its access after you ship it outside your doors, or can you robustly leave it inside your boundary and just provide access as long as it's appropriate? I mean, those are two different approaches, but you still have to keep your hands around the stewardship you're obligated to protecting that data. Or at the very least, if you ship it outside your control and now it's just out there, can you audit your environment robustly enough and know that if that sensitive information were to become publicly disclosed, that the source was not your environment? You can audit that access and how it moves, the data in use aspect and data in transit. At that point, if that breach happens, can I prove it didn't come from me? It came from some third party. So and that's not a great situation either, but at least you can affirm that your controls were intact.
If I could add a few words, there is a different way of defining the notion of confidential computing. Rich has given a sort of historical, general sort of introduction. In cloud technologies, and in particular in recent trends, the term confidential computing has acquired a particular meaning, a particular form of technology. The basic idea is that recent trends in hardware provide cryptographic features in the machines that are coming out, manufactured by Intel, AMD, etc., and generally available on Microsoft Azure, Google Cloud, AWS, etc., that allow the construction of isolated and protected real-time computing environments. And these real-time computing environments are hardened by the use of inbuilt public key cryptographic infrastructure. So imagine that you are going to run your workloads in completely protected and isolated real-time computing environment, which is using PKI to protect the boundaries of that environment. And all the data and the program, the code asset and the data assets that are inside this hardened enclosure, if you want to call it that. It's usually typically called a secure enclave. If all the assets inside the secure enclave are completely protected by the hardware itself, you have to physically destroy the machine, try and get at the data. So the custodianship problem that Rich was referring to becomes you transfer the custodianship of the data assets to the machine itself. The machine protects the data, and it is and you can produce an audit log generated from within the secure enclave of the machine that says that the data was protected that the custody of the data was with the machine itself, and you produce an irrevocable and immutable audit log that, mathematically speaking, produces a proof of custodianship from the machine itself. It is now entirely possible to take those kinds of proofs of access and proofs of data privacy and construct compliance reports that would satisfy the data privacy rules and regulations. So confidential computing, in some sense, has evolved into a new set of cybersecurity protocols that allow the construction of isolated and protected environments. And these runtime environments are the basis of a new set of data privacy technologies and data custodianship properties.
Shamim, following what you just said, would you say the use of confidential computing and privacy enforcement of technology guarantee complete security of user data?
Yes. Yeah. Let me, in fact, spend a minute and try and elaborate what I'm saying. We generally assume that data in transit and data in stored technologies use various forms of encryption technology to protect the data. And the keys used for this encryption are managed by vault systems, etc. You asked previously if there were certain points and vulnerability stages. One of the very common vulnerability stages that your key store may itself get hacked. And if that happens, then all the protection that you are getting out of your encryption technology are no longer valid. In confidential computing technology, the private keys are generated from inside the secure enclave technology and are not available outside the secure enclave. So therefore, anything that you encrypt, and in particular, the data that you encrypt in use, cannot be leaked outside of the secure enclave. So everything is and can be encrypted. And the keys used for that encryption are only known to the internals of the hardware of the secure enclave itself. Since the keys never leave the secure enclave, therefore, the only possibility for you to hack is to hack the secure enclave. It's a zero trust mechanism in which you have explicit trust in the secure enclave technology to protect the keys of the encryption scheme being used. So therefore, you can, in fact, make a claim that the data is protected by the machine itself, not by an organization, and not by using some other kind of technology or wrappers, and Rich refer to the various ways in which different technologies are used. This is security from the ground up, from the inside out, if you want to phrase it in that way, in which the machine, its hardware, is being empowered and is manufactured to protect, to offer an encrypted regions of memory that are protected by the hardware itself. And audit logs are generated by the machine itself to prove that the data was protected when it was being used. So in that sense, it is completely mathematically provable.
Are you referring to the trusted platform module mechanism?
It started as the TPM, the trusted platform module, but it has now sort of evolved into where the CPU instruction sets, in fact, are being built. So yes, in a previous generation of technology, it was the TPM, but now you have these modern CPUs that provide new set of instructions that allow the cryptographic features to be invoked on that basic machine itself. So it's a very sort of exciting development. We are at an era where we can ask the hardware to protect the code and data assets of the machine. And this protection is a ground-up protection, not sort of added in at the software layer level, but at the level of the physics of the hardware.
Rich, what would you say the common techniques to turn public cloud workloads to private one?
And I'm sorry, I lost a word in transmission. Can you repeat the question, please?
Yeah. What would you say are the common techniques to turn public cloud workloads into a private one?
The techniques to turn public workloads into private workloads?
Yeah, it doesn't mean like moving back to the on-prem, but how do I make it private for my organization so nobody else will be able to have access to my data?
Yeah, well, so there's two contexts I think you need to approach that with, and one is, are you going to improve your DevSecOps and similar operations like CI/CD and everything else that involves managing more of the plumbing, or if you're talking about in a SaaS nature where you control as little as possible, then I think it still comes down to secure compute concepts where you are maintaining cryptographic or other access control mechanisms within that platform. So making sure that you're following all of the available guidelines from benchmarks, from the vendor or from an authority like CISO or whatever your favorite flavor for hardening is. And that's sort of a virtual equivalent of privatizing it, because it's, again, the systems are geared towards ease of use, and that ease of use is a trade-off for confidentiality and proper access to the appropriate parties. It's hard to speak to it more specifically unless we start talking about specific contexts. But in principle, I still feel like it says who's accessing it and how. And without talking about a particular platform, which we're not here to do today, I don't know how much more specific I can get. I like at the end of the day, when you hold the encryption around something and you can release it dynamically just in time and for the right amount of time to data, as the best way to keep control across any situation, whether it's public SaaS or private, containerization, either way.
If I could add to that, typically when you upload your data into a public cloud, the cloud provider, the cloud service provider, holds the keys of encryption and manages your data at rest and data in transit. In that sense, the custodianship of the data goes to the cloud service provider. You are depending on the cloud service provider to provide the security of your stored data. If you want to turn your public cloud assets into a private cloud asset, in which then you have to say that a literal sense, you manage the keys of encryption, not the public cloud provider. So how do you do that? In confidential computing, the keys are being managed by the hardware itself. So you take the cloud provider out of the equation, you take everybody out of the equation. It's the machine that is generating and protecting the private keys. And those keys are being used to do this encryption. And so confidential computing technology is providing you a very clear answer to the question that you asked. To turn your public workloads into private workloads, you have to spin up confidential computing machines that allow your data keys, your keys of encryption, to be managed by the machine itself, so that the keys are not in the purview of the cloud service provider, and they in fact are not even in your purview. The machine guards them, the machine generates them, and the machine produces an audit report as to the integrity. You, Rich, previously used the word attestation, and you used the word measurement. These have a very technical meaning in confidential computing. The word attestation in confidential computing means that the machine attests to its integrity. Measurement means that the workload is measured to be exactly the same as a baseline version stored in the code owner's asset library. So measurements, attestations become technically viable concepts that have particular technical meanings, and they are used in the compliance reports that are generated by that secure enclave, where the data resides, and the keys are being managed by that secure enclave. So the private workload that you construct by using secure enclaves then assumes the custodianship of the data.
One question came to my mind. Many organizations are using the cloud to store a lot of data and to do analytics on top of the data. How does confidential computing allows us to keep data private when we have a lot of data that we need to analyze it?
Well, the classical answer to this has always been that you use homomorphic encryption, in which the data is always encrypted, remains encrypted, is never decrypted, and you do your processing of the data on the encrypted data set itself. This is often known as the holy grail of computing, in the sense that if it could be done that way, then since the data is never decrypted, you can share the data and you can allow it to be processed by any computer program. Unfortunately, the state of homomorphic encryption is such that the performance makes it largely impractical. So the next best alternative, in my viewpoint, is that you always have encrypted data, and that the processing of that encrypted data happens inside a secure enclave using confidential computing technology. And the data is decrypted inside the secure enclave using keys generated from inside the secure enclave. So only the secure enclave, in some literal sense, sees the data. And when you finish the processing of the data, you re-encrypt the data and it comes out of the secure enclave. And the computed results of the data, the purpose of the analysis, also the results are also, in fact, encrypted. If that happens, then you can claim in a literal mathematical sense that the secure enclave was the only place where the decryption happened. You can prove it by recourse through the audit logs of the secure enclave and through the key and through the private key mechanisms. And you can prove that no leaks happened of that data. So you can, in fact, have the possibility of giving an encrypted version of your data set to a partner organization, as long as the data is only processed within a secure enclave. They would not be able to view the data. They would not be able to view the results. They will be able to process it inside the secure enclave and return the results back to you. And that is a workflow that is achievable today. We are, in fact, in SafeLiShare, we are doing a proof of trial with a partner organization exactly along those lines, where data is coming in from a partner organization. It comes in encrypted form. It is decrypted inside a secure enclave. It is processed by a model, and the results are computed, and the results are encrypted, and the results go out in this encrypted form. And nobody sees it. Nobody sees the data. Nobody sees the model. Nobody sees the results.
Rich, from your experience, many organizations are doing artificial intelligence and using cloud computing to do so. How does artificial intelligence factor into predictive analytics and data privacy?
Well, I think what Shamim was talking about is really key to this. The way, AI is really just more advanced processing of data, and that's fine. But what we're really talking about in a secure computing fashion is, how are you sharing data? Because whether it's to a very basic data processing mechanism or the marvel of AI, it's all the same. You're exposing data. And I think that the notion of being able to provide either, I can't think of a better way than what Shamim was talking about, because at best in the past, we would share metadata or key data points and try not to disclose more or shove more of our data than necessary to process for a particular result, a particular analytic. We would often gather only metadata if that would suit our needs for the business purpose, whatever we're talking about, and not hold data so that our scope of data would be minimized, right? We never solved the problem by protecting the data. I mean, we do that at the end of the day, but the strategy has always been reduce the data that you have to protect, because we feel like we can't do that job. And the idea of secure computing really transforms the possibilities. So I don't think it's about AI. I still think it's about, because that's just an engine that would put focus on something. It's still about securely sharing that data to the proper level of its sensitivity and getting that result back in a protected fashion. Yeah, I think Shamim put it best. The issue is sharing it.
There's a notion in machine learning. There is a sub-genre of machine learning called private machine learning. And in private machine learning, the issues at hand are, how do you train your models using which, and of course we know in many use cases, the amount of data that you need to train your models is extremely large and cumbersome. And if that data contains private and sensitive information, then you have the problem of either cleaning the data before you feed it to the model and use it for training purposes, or you somehow make sure that the machine that the model that you train doesn't learn the private information of patients and people and consumers, etc. And then, of course, there is a phase in machine learning in which the models are required to operate on real-world data. And so this notion of confidential computing is at the heart of the notion of private machine learning. If you can train your models on real-world data, and the models contain all kinds of private and sensitive information, then the model really should also run as any other sort of analytic program inside a secure enclave and protect the model's information that is being used to train the model itself. So there are several startups that are looking at the use of confidential computing, using it to train models in which the privacy of the model training data is at risk.
Thank you, Shamim and Rich. Thank you for being us and having this conversation. And thank you, everyone, for joining our Data Privacy Day.